is your video for 7.4 exponential growth and decay. And this is really going to have two sections in it. So I am probably going to make this a two-part video just so it's not so incredibly long. The first topic that we're going to look at is separable differential equations. And this is a very, very common topic in the free response question section on the AP exam. So a differential equation of the form your dy dx is equal to some function of y times some function of g is called separable. We separate the variable by writing it in the form 1 over fy dy equals g of x dx. So basically you're going to divide by whatever the function is that has the y in it to move it over to the left with the dy. You're going to multiply by the dx to put the dx then on the right so that you have the x terms on one side and the y terms on the other. Then we find the solution by anti-differentiating each side with respect to its thusly isolated variable. I only have one example in the notes for this, but I am going to find some other examples online so that you guys can see what this looks like. We will also be working with this in some free response question problems, but this is something that I can almost guarantee will come up on the AP exam. Okay, so here is example 1. We need to solve for y. So not only are we getting the y by itself, we also, it says solve for y if we know this differential equation and we know that y equals 1 when x is equal to 1. This information is going to allow us to find our c value. So we are going to find the c value here. You do need to distribute the square. So this is x squared y squared as our equation. So now I need to put the y's on the left-hand side, the x's are going to go on the right-hand side. It's called separable because we can take it apart. The dy over dx, I can multiply both sides by the dx to put the dx on the right, and then I'm going to divide by the y squared to put the y squared on the left. So I have 1 over y squared times dy is equal to x squared dx. So we're separating, we're integrating. So I'm going to integrate both of these. Now, whenever you integrate, you actually only need to put the constant on the one side. And typically we put the constant on the right-hand side of the equation, because if you had one constant on the left and a different constant on the right, and you subtracted that constant on the left over to the right-hand side, you're going to get a new constant. So it just saves us some time by just putting a solitary constant on the right-hand side. So if I do the antiderivative here, this is going to give me negative y to the negative 1 is equal to 1/3 x cubed plus c. Now, this is the spot where I would suggest plugging in the 1 for x and the 1 for y. That will allow us to find the c value. So we have negative 1 to the negative 1 power, which is going to be negative 1, equals 1/3 times 1 cubed. So I have negative 1 equals 1/3 plus c, which means c is negative 4/3. So now I'm going to come back to this step here. I have negative y to the negative 1 is equal to 1/3 x cubed minus 4/3. If I get rid of the negative out in front, that's going to be 4/3 minus 1/3 x cubed, or you could call it negative 1/3 x cubed plus 4/3. This entire thing, because in order to get rid of this y to the negative 1, because this is really the same thing as 1 over y, so eventually I'm going to have to do a reciprocal. I can rewrite this as a solitary fraction. This is 4 minus x cubed over 3. So if y to the negative 1 is equal to that, y is equal to 3 over 4 minus x cubed. And we could go back through and take the derivative of that to make sure that the dy dx is equal to x times y, the quantity squared. Okay. So again, I will put some other examples for this into your into the notes folder, or actually into I've been making Khan Academy folders that have all this other information in it. So those are going to be present. So next, typically when we have our dy dt, if you state that you have some differential equation where you have some type of constant times your original function y, this is really the process you would go through to separate that. Notice that I left the k term on the right-hand side here with the dt, and then I put the y over on the left-hand side like I did before. If we do the antiderivative of 1 over y, that's going to be natural log of y, and so that's going to equal kt plus c. And then I did this e layer, because if I need to solve for y, I have to raise each side to the e power. E to the natural log y is just equal to that absolute value of y. And so that's e to the kt times e to the c, because when you have an e to two things that are being added, that's the same thing as you multiplying originally. We can get rid of the absolute value by putting a plus or minus in front of the e to the c. And then e to the c is actually just going to be some type of constant a. So this formula here, this y equals a times e to the kt, that is going to be a typical solution for a differential equation where you have some constant times the original function of whatever y was. This is a very, very common format as well on the AP exam, and you will be seeing some examples with this. So this ties directly in with our law of exponential change, only instead of that capital A, we actually have a y sub 0 here, where y sub 0 is typically going to be like your initial amount that's present. If k is some positive number, that's going to be growth, and if k is a negative number, that's going to be decay. K is our rate constant in the equation. So this is just one of those laws that we will be working with. A lot of what we're going to do in the rest of this section is more like higher pre-calc stuff rather than necessarily calculus stuff. So some of this you may recognize from previous classes. Two other formulas that you're going to have to know for the homework, and possibly for an exam, but not for the AP exam. I don't see these happening on the AP test. You have the PERT formula. That's where you have interest that's compounded continuously. So P is going to be the initial amount. R is going to be your rate of continuous interest. T is time. And then E is just the letter E that's on your calculator. Then you have interest compounded N times per year for T years. So if you're compounding quarterly, N would be 4. R is still rate. And then T again would be however many years you are investing your money. So that brings us to example 2. These are really going to be calculator examples. So it says, suppose you deposit $800 in an account that pays 6.3% annual interest. How much money will you have 8 years later? So that's going to be our T. And then we want to know if the interest is compounded continuously. Continuously would be our PERT formula. And then compounded quarterly, that's going to be the second formula, and that's going to be where N is equal to 4. So for the first one, A of 8 is going to equal my $800 initial dollars times e to the, you do have to take your rate and change it to a decimal. So that's going to be 0.063 times the number of years, which is 8. And that's going to give us $1,324.26. For the compounded quarterly, we do still have the initial $800. Then we are multiplying that by 1 plus the rate of 0.063 divided by 4, because it's compounded quarterly, and then to the 4 times 8 power, so it's NT. This is going to give us $1,319.07. So you can see the compounding continuously gives us a slightly higher dollar amount than the compounding quarterly. The last thing that we're going to look at in this video is going to be half-life, and this will then continue into our first example on the next video. It says find the half-life of a radioactive substance with decay equation y equals y sub 0 e to the negative kt, and show that that half-life depends only on k. So half-life means that after a certain amount of time has passed, so we are going to be solving for time. That's our goal. We're trying to solve for time here. If one entire half-life has passed, that means that half of the original function is left, or the original amount. So my y is going to be equal to half of the y sub 0. Well, if we solve this equation for t, the y sub 0's divide out, we get 1/2 equals e to the negative kt. I'm going to solve this by taking the natural log of both sides. So this natural log of 1 over 2, well, it's natural log 1 minus natural log 2, but the natural log of 1 is 0. So it's really just negative natural log 2. Natural log of e to the negative kt is negative kt. Which means I would divide, if I'm solving for t again, I'm going to divide both sides by negative k. T is equal to the natural log of 2 divided by k. And k is whatever your rate constant is. So anytime you have to find the half-life, it doesn't actually matter how much of a substance you started with. All you need to know is what the k is. K is going to be the rate constant, and of course that will change for different substances. So that's where I'm going to stop for right now. We will come back and do more with half-life. Example 5 actually has some more stuff having to do with half-life. So go back, rewatch the video, really focus on example 1, because that is one that will definitely be on the AP exam. The rest of this is just kind of making those connections between differential equations and some other stuff that we're using in class. So, as I said, go back, rewatch this, and reach out to me if you have any questions at all.